Welcome, RRISD second grade teachers, to this explainer covering everything you need to confidently launch Unit 2 Matter and Materials. We know your prep time is absolutely precious, so we've distilled your source materials into this one visually guided overview. By the end of this, you'll be 100% ready to teach this science unit. Here is our roadmap for today. We'll quickly cover the unit TEKS and mastery, dive into the core science concepts, figure out how to tackle common student misconceptions, walk through your hands-on investigations, and wrap up with vocabulary and your interactive word wall. All right, let's jump right into Section 1, Unit TEKS and Mastery. Knowing exactly where we're going is the best way to plan the trip, right? For this unit, we're focusing on three main TEKS. First up, TEKS 2.6a has students classifying matter by observable physical properties. Think texture, flexibility, and temperature, and identifying if it's a solid or a liquid. Then, TEKS 2.6b is all about conducting descriptive investigations to see how those properties can be changed by things like cutting, folding, sanding, or melting. And finally, TEKS 2.6c asks students to show that small units can be combined to form an entirely new objects, and to explain why certain materials are chosen for specific jobs based on their properties. So, what does mastery actually look like here? Well, it all comes down to the final performance task. Students are going to observe objects, sort them by physical properties, and then write a claim evidence reasoning, or CER, response. They need to prove whether a building brick is a solid or a liquid. If they can independently sort things and explain that a brick keeps its shape and can't be poured, boom, they've mastered the unit. Moving right along to Section 2, Core Science Concepts. Now, you don't need to be a seasoned scientist to teach this well. You just need a firm grasp on a few key principles. The absolute biggest takeaway for students is that physical properties dictate utility. Put simply, we pick materials based on what we need them to actually do. A house is a great example here. Bricks are super strong and sturdy, perfect for building walls, but you literally can't see through them, which makes glass the clear, functional choice for windows. It's all about matching the property of the material to its purpose. You're also going to need to clearly contrast states of matter. We want to keep it accessible but highly accurate. A solid is an object that strictly keeps its own shape, no matter where you move it. A liquid, on the other hand, flows and takes the shape of whatever container you pour it into. This simple binary distinction is exactly what your second graders need. Finally, emphasize that matter isn't just stuck the way it is. We can actually change physical properties by cutting, sanding, folding, or melting. You'll explore this using everyday objects, like different kinds of spoons. It's a brilliant way to show that even though they are all spoons, their texture, flexibility, and temperature vary wildly, depending on what they're made of and how they were formed. Up next is Section 3, Addressing Misconceptions. Let's be real, kids, and honestly, some adults too, come to class with a lot of preconceived notions. Let's anticipate the biggest roadblocks before they happen. One major misconception you'll encounter is that objects are only grouped by basic appearance, like color or size. If a kid sees two red objects, they might just instantly lump them together. You're going to need to actively redirect them to look at deeper physical properties. Is it rough or smooth? Does it bend? Is it hot or cold? Okay, here's a really interesting one, sand. You are definitely going to hear students argue that tiny things like sand or salt are liquids because, well, you can pour them out of a bucket, right? This is such a great teaching moment. We have to reinforce the correct understanding. If you look really closely at a single grain of sand, that individual grain strictly keeps its own shape. It does not morph to fit the bucket. So sand and salt, absolutely solids. Also, keep an eye out for the idea that materials only serve one single purpose. Kids often think a toothpick is just a toothpick. You'll need to guide them to see that combining basic units creates completely new objects with brand new uses. A toothpick and some clay can easily be reassembled into a towering bridge. Which brings us to Section 4, Investigations and Modifications. Let's talk application. For the Build a Tower engineering investigation, students get to act as engineers, brainstorming and assembling structures to build the tallest tower possible. You'll set up stations with spaghetti, toothpicks, tape, modeling clay, and chenille stems. But here is an absolutely crucial safety note for you. Please make sure every single student is wearing safety goggles during this, and firmly remind them to be careful with the sharp ends of the toothpicks and wire stems. To make sure we're reaching every single learner, especially our emergent bilingual students, we have some great supports ready to go. For beginners, use lots of gestures, like bringing your hands together for the word combine, and stick to yes-no questions. Give your intermediate learners extra oral response time and sentence tense so they can practice the academic language before they write. And for your advanced students, challenge them to really discuss the why behind the engineering design process with their peers. And finally, Section 5, Vocabulary and Word Wall. Consistency here is a real game changer for building academic language. We're going to use total physical response, or TPR motions, to build strong muscle memory. Have your students hold up imaginary binoculars to their eyes when they say physical property, representing that it's something we observe. Have them rub their fingers together for texture, and actually bend their arms back and forth for flexibility. Build on that physical vocabulary by having them spread their arms out wide for matter, since it takes up space. They can hold their fists firm and rigid for solid, make wavy, flowing hands moving downward for liquid, and quickly shift their hands around each other for the word change. Getting the whole class moving makes the vocabulary stick in a really fun, engaging way. Now, for your interactive word wall, we want you to use the exact scripts provided in the curriculum. Model the specific sentence frame out loud, speaking clearly and deliberately. The materials, blank, and blank are both blank because blank. So, for example, the materials glass and ice are both smooth because they have a flat surface. This ensures students know exactly how to use our target academic language. When you move to states of matter, use this specific script from your notes and read it with them. A solid is an object that blank. Blank is an example of a liquid. Liquids are different from solids because blank. Hearing you deliver it exactly like this models the expected scientific communication they'll need for their own CER writing. Wrap up the word wall with this final frame. I can change matter by blank. The shape of an object can be changed by blank or blanking it. This perfectly ties right back to our teaks regarding cutting, folding, and sanding. And with this roadmap, you are completely ready to teach this unit. You've got the teaks, the science, the misconceptions, the investigations, and the vocabulary all locked in. So as you head into your classroom to set up your word wall and your spaghetti towers, ask yourself, how will this newfound understanding of matter transform the way your students interact with the everyday objects around them? Have a fantastic time teaching Unit 2, and thanks for joining this explainer.